Hello, everyone. Thank you for joining DataCon LA 2022. Welcome to MySQL, JSON, and you perfect together. So we do not have any COVID regulation as of now, but you can keep on wearing a mask if you would like to. This session is currently streaming via Zoom and will be recorded. It will be available online in a few weeks. Today we have our guest, Scott Stroz from Oracle, and he will be talking about MySQL, JSON, and you perfect together. So with further ado, I'll hand over to Scott. Thanks for being here.
Thank you. It's a pleasure to be here. There we go. First of all, before we get started, is the obligatory I love me slide. This is where people tend to brag about themselves. I'm a developer with 20 plus years experience. In the entire 20 years that I've been a developer, the only constant in my development stack has been MySQL. It's the database I first used in the first web application I ever wrote, and I'm still using it in web applications that I build and I work with today. I am currently I'm currently the MySQL developer advocate for Oracle. I am an avid golfer, and as you will see, a lot of the data we're going to talk about is golf related. I'm a diehard New York Giants fan, and I have the best office mate in the world, my dog Murphy. When my wife works, Murphy's in the office with me all day long, and he keeps me sane. So what are we going to cover today? We're going to talk about what is JSON. We're going to give a definition of what it is and talk about the syntax. We're going to talk about storing JSON as a string data type as compared to storing JSON as a JSON data type. We're going to give some examples of why would you want to store JSON in a database. We're going to talk about how you persist JSON, how you retrieve JSON, how you up JSON in a MySQL database. We're going to show you some examples about how you can use relational data and return it as JSON, and then vice versa, how you can take information that is stored in a JSON blob and actually return it as relational data in a query. And then lastly, we're going to spend a little bit of time talking about MySQL Document Store, which is MySQL's JSON document storage, similar to MongoDB, but it's built on MySQL. So first of all, what is JSON? JSON is an acronym. We love acronyms in technology. This acronym stands for JavaScript Object Notation. For the purposes of this session, we just need to remember that JSON is a textual representation of a data structure. So it's a string. And we can, when it comes time for inserting, you'll see we just treat it as a string. Objects are wrapped in curly braces. Objects can have key value pairs where the key is also, the key is in double quotes. Depending on the data type that's being passed in, it may or may not need to be quoted. So for example, Booleans are not quoted, numbers are not quoted, strings and dates are. You can have arrays. You can have arrays of objects, you can have arrays of simple values. Those are wrapped in brackets. In a JSON object, data can be nested. That means we can have an object that has a key that is an array, where each element in that array is then an object. And inside of that object, we might have another property that is an array that has an array of simple objects. And the nesting can actually go, n numbers deep. It doesn't have to, there's really no hard limit. And best part is it's language independent. What that means is if you have a valid JSON block or JSON blob and one language can interpret it, any other language that can interpret JSON can also interpret the same thing. I don't remember where I first heard this, but I remember it being very early in my career as a developer. Normalize until it hurts, denormalize till it works. When I first started looking at some of the JSON stuff that's available, not just in MySQL, but in other databases, this came to mind because when you're storing JSON in the database, to me, it almost seems like we're denormalizing. I'm going to explain why that is sometimes a good thing. So why would we store JSON in a database instead of in relational tables? If you're starting a project from scratch, it can actually lead to faster development time. If you don't have to worry about having a DBA or somebody run SQL scripts against a database and making sure that those scripts get sent out to everybody else so that they're using their own local version of the database, sometimes things can get out of sync. it's better to maybe not have a schema. The schema is going to change a lot. Why bother having a schema until you're sure that you're close to what you need? So if you're starting out a project and instead of using relational tables, you store the stuff as JSON, then once you get to the point where you're mature enough to know what your table structure is going to look like, you can then use the built-in JSON functions to automatically populate the tables that you want to create afterwards. JSON is a lot less verbose than XML. I don't know if anybody here has ever used XML for user configuration and stuff like that, but it can be a nightmare and it's very, very verbose. I think JSON is very easy to read. I didn't when I first started using it, but I changed that now. Pretty much every programming language has a way to read JSON. I don't know of any language out there, none of the languages I've used are difficult or make it so that you can't use JSON. They all have ways to serialize or deserialize JSON to and from strings. And then there's some data that's just unstructured. Relational databases are great when you have structured data. When you don't have structured data, they can be a nightmare to maintain, especially if you have a lot of properties that might not necessarily relate to anything else and really don't make a whole lot of sense to be in a database. Some of those examples, user preferences. I worked on a project for the US government where we had a lot of kendo grids on a variety of pages. And the client wanted us to be able to have the users save configurations of those kendo grids. So they could hide show columns. They can filter things a certain way. They can enter in certain other search criteria. They can rearrange the order of the columns and then save that information. And we were actually saving that as a JSON blob because it was easier. It was easier to maintain. And actually, I'll get to this in a second, we were also able to validate that what we were passing in was actually valid for what we were looking for. That's something, if we were to put that into relational tables, would have been a nightmare. And it would have taken a lot of development time. Configuration data. In the first part of the session, when we're showing using JSON, I'm actually using real data from a golf league that I manage. And one of the things I do is for each season that we have, I have a JSON blob that has all the configuration data for the start date, how many teams there are, how many golfers there are per team. Any information like that that could change where I can either add or remove functionality from, I found it's easier to just store it as a JSON blob and I can update it and remove it and add to it very easily without having to make changes to my DDL. And also, another thought I had is feature flags. If you're working on a project and you have the concept of feature flags where you start working on functionality and you're like, if this feature exists or if this client paid for this feature, then we can show a button or something along those lines. It might be easier to keep that configuration in feature flag or in JSON rather than, again, in relational tables. So the JSON syntax. This is an example. As I said, objects are wrapped in curly braces. So you see what we have here is we have a single object. There is a name property. The name is Scott Stroz, which is me. Number of children is 2, which I do have. And I play golf. The friends property is an array of friends of mine. Raymond Camden, who has 8 children, and he does not play golf. And no, those 2 are not related. And my friend Todd Sharp, who has 2 kids, and he also plays golf, not as often as I do, though. So this is just a basic syntax. This is showing that we have some properties where where the value is a string, some where there's a number, some where there's a Boolean, and one of them where there's an array. Storing JSON as a string versus storing JSON as a data type. So long before the JSON data type existed in MySQL, developers were storing JSON in the database, but it was usually stored as a car, a var car, text, clob, whatever, anything that would hold a large amount of text. People were storing JSON in. The only way you could search that is if you used like or regular expression. Because as far as the database knew, it was just text. It didn't know you were dealing with an object that has properties or it has keys and values. It was text. It was no different than having 5 paragraphs of a Stephen King novel stored in your database. And another problem is updating any of the values required you to update the entire string. So in this particular case, if you had one property that changed, you had to go and do an update and pass in the whole new JSON blob into that in order to update it. With the JSON data type, which was originally introduced in MySQL 5.7, it is designed to hold valid JSON documents. Notice valid is red and underlined and bolded and italicized. That's because if you just tried to pass in something that was not valid JSON syntax, I'm not talking based off of a schema. We're going to get to that. But if you just tried to pass in something that was not actually technically valid JSON, it's going to throw an error. It's not going to let you do the insert. It's actually stored in a binary format, which makes it more optimized for replication as well as quick searches. Something you'll realize if you start playing with this, if you add a JSON object to the database and then read it back again, you might notice that the keys are going to be in a different order than what you put them in. That's because of the way that it handles the data on the back end, where it stores it as a binary, and it actually makes it more efficient to pull information in search. And honestly, it doesn't matter. The arrays, when you put in an array, the arrays will be in the same order, but if you have an array of objects, the keys will be different, but they could be different than what you put in, but they will be consistently the same order when you pull them back. And you can actually define the schema. So if you have something where you're going to store your information in JSON. Now you might be going, wait, if we're doing schema list or JSON, why would we want to define a schema? Because you may have an object that has a particular key that you want to make sure that that key is a number. So you can actually add a check constraint that validates whether or not what came in is actually a valid JSON block according to your rules. So creating a table with a JSON column, it's really easy. You'll see here, season settings, I have the data type of JSON and the default of null. That's it. That's all you have to do. Now you'll see underneath where the yellow arrow is, I have a check condition in there. And what we're doing here is we're adding basically validation. We're defining what the schema is. And in this particular schema, the JSON schema valid in that particular function, what you do is you pass in the schema that you want and then the column that you're checking. So the first thing we're doing is we're actually defining an object. We tell it it's an object. If it's an array, it would say type array. And we're saying the properties are league fees and that it must be a number. Now there's also there's another property we can add to this JSON blob for the schema that says what is required. So if you need to make sure that when you're inserting JSON, there are certain keys that have to exist, you can add that as well. And again, if you try to insert that without those keys, it's going to throw an error. Inserting JSON is probably the easiest thing we're going to talk about today, because remember I said it's a string. It's just, in terms of inserting it into the database, you treat it just like any other string. So you just do a simple insert into and pass the string. In the insert, that we're doing here, you can actually see what we're doing is we're passing in the name of the league, which is stored in a column, the start date, the league ID, and then the season settings is actually what the JSON is. And you can see here, we're actually just passing in an empty object. We're not setting any properties or anything on there. And if you do a select star from with the ID that was created, you'll see the output along the bottom where you can see the season settings is just the curly braces and nothing else. But we're going to be adding stuff shortly. So for this part of the demo, this is what the schema looks like. Okay, this is going to be, and this is actually a scaled down version of what I had, because I actually have a lot of different settings on the application I wrote for seasons. I just narrowed it down to a few. We have a course property, which is an object that has information about the golf course where the season is going to take place. We have a scoring object, which defines how the scoring is actually done in the system. We have a subpool. Some of the leagues that use the software actually allow people to come in and play as subs, and there's a variety of different rules that can be used. So the subpool is an array where each season we can set which type of substitute there are. There's a Boolean for uSub. So obviously, if uSubs is set to false, then the sub pool would actually be an empty array. How much the league fees are, that's what the golfers pay every year at the beginning of the season. The greens fees are how much they pay each week when they show up to play. Whether or not we have contests available, how many points you get per hole, and finally, how many golfers there are per team. Again, this is probably about a third of all the probably about a quarter of all the different properties I have available for seasons on the app that I wrote. Something I want to talk about real quick before we go in, because this is going to be important as we get into some of the other functions that I'm going to talk about. When we're talking about a JSON object, a lot of times when you talk about pathing, especially if you have nested objects, so or nested values. And the pathing is basically how we get from the root to the particular property we're looking for. And if you don't know what keys are available to you, you can use a function called JSON keys, and you pass it in the column. And what that does is that will parse the JSON that exists in the table, and it will return an array of the different properties that exist. So here you have all the ones that I just rambled off. A nice debugging function for JSON is JSON pretty. What that'll do is if you run that in a console, it'll actually format the JSON nicely. If not, it'll just be one really long string on one line. You really don't want to use that in production. I honestly don't know what it's going to do. I don't know if the extra line breaks will cause problems, but it does. If you're using an IDE or anything, it does make the JSON a little bit more easier to read. So you'll see here, JSON keys, we just passed it season settings. There is an option with JSON keys to pass in the path. So as I just said, the scoring property of a season is actually an object. So what do we do if we want to see the keys for that object? Well, you see the second argument we have now, we pass in a string, which is $. And when we're dealing with the JSON functions with a JSON data type, $sign is the root. So whenever you see the $sign, that means you're starting at the top of the object. So if we want the scoring property, we do $.scoring. So that's what we're passing this here, and you'll see what'll happen is you get the title, the description, and the handicap type come back as the keys. The pathing you're going to see that's going to come into play. And if scoring had another property that was an object, we could do $.scoring.other property, and you can keep that going down into all the different levels that you need to get to the data that you want. Okay, querying the database based on values in a JSON block. So we have data in our database. It's a regular relational table. It just happens to have a column or columns that are JSON, has the JSON data type. The first thing is JSON contains. This is usually going to be used in your where clause. I'm not going to say it's always going to be used in your where clause, but it's usually going to be used in the where clause. And basically what you're saying there is, does the JSON blob named season settings have a value of 70 in the property called league fee? And again, remember that with the pathing, that's $.league fee. So that's the main, it's off the first branch of the object. That's all we're doing. This will actually return 1 or 0. 1 if it's true, 0 if it's not true. So again, that's why I said it's going to be mostly used in the where clause, because I don't know why anybody would want to return that as a value in a query. You'd probably want to be like, give me all the, so what we're saying here basically is give me all the information from the season where the league fees are $70. And you'll see those will be the results over on the right-hand side from my data set. Something to be careful of when you're doing JSON contains with strings. I don't know if anybody noticed, but in the last slide, the 70, which is a number, was actually in double quotes. Okay? That's the syntax you need to use for numbers. For strings, that won't work, because if we only just put Charlestown in single quotes, nothing would come back. You actually have to do single quotes and then double quotes around the string you're looking for when you're using JSON contains. Okay? There's other ways that you can get the value. There's other things you can do that are going to be a little bit easier than JSON contains. This is just for JSON contains that you have to have that double quote. Now, something else I want to show you on this slide, which I think is pretty interesting, is the fact that you can actually return JSON data as a table using the JSON table function. This particular function, it takes the season settings, which is the column that we're using as the JSON, and then the $, subpool, bracket, asterisk, bracket, is saying in the subpool property, which is an array, give me all the information in that array for those two properties. And the two properties are $type and $name. Okay? And if you look at number 3, you'll see another JSON function. This one's really handy. It's called JSON array ag. And what that does is that will actually create a JSON array of aggregate data. Or if you have a query that returns multiple rows and all you're doing is select JSON ag and passing in values there, you'll actually get a JSON array returned. In this particular case, what we're doing is we're creating a join with a JSON table. And in some cases, that join is going to cause more rows to be returned for a particular season. JSON ag condenses them into one thing. So it's kind of like using group by as well. And then you see, this is what the result actually looks like. So you see, we pulled in the ID and the name of the season, and then the sub roles, you'll see those are actually arrays. And the last 2 items, there's actually 2 items in the array as opposed to everything else just having 1. Array ag it's a function that's really cool, and it can do a lot of things, but sometimes you might get the syntax wrong, or you might be thinking about it wrong. So the way I look at it is, if you would normally want the information grouped in a group by, then you probably want to use JSON ag if you want to get aggregate or you want to get data in JSON. JSON value. JSON value is actually a little bit easier, I think, to use than JSON contains, because here what we say is, if you look in the where clause, we have where JSON value, again, season settings, and we're looking at the state property of the course property of the main object, where it equals WV. Notice the WV is just in single quotes. It's not in double quotes, or a single quote and then double quote. The other good thing about JSON value is you can actually cast it to a different data type. Unfortunately, the syntax is not cast, it's returning. So in this particular case, we're using JSON value to say, hey, get me the greens fees property of the season settings, but I want you to cast it as a decimal with 2 decimal places. And you'll see where the yellow arrow shows, that's how the number actually shows up in the query. Okay, using path operators. There's 2 types of path operators, and for me, these are easier to read than some of the other functions that we have available to us. And the first one you'll see marked with the yellow arrow, it has a hyphen and then 1 greater than sign. That will return whatever is inside of that particular property. If it's a string, that means it's going to be returned wrapped in double quotes. I've got to be honest, I don't find that helpful at all, because I don't think anybody's going to want to see that data quoted like that. But if you do dash with 2 greater than signs, you actually get the value that was in that particular property. So if you see the course name property, I use the first path operator, and it's got the quotes. For the course city, I use the second path operator, and it doesn't have the quotes. You're probably going to use the hyphen the hyphen greater than more than anything else. That does not affect numbers or booleans. It will affect dates, however. Because remember, it's a JSON string. JSON doesn't know dates from dates, so it treats a date as a string. Updating JSON values. So now we have our JSON that's stored in the database, and we want to make some updates to it. Remember I said before in the past, what we'd have to do is we'd have to update the entire string if we were storing the JSON as a string in a string data type. With JSON data type, we don't have to do that. We have 3 different ways that we can update data in a JSON data type. The first one is JSON insert. It simply inserts a key into a new JSON, or a new key into a JSON document. What it won't do is it will not update a value if that key already exists. So for example, if I want to insert, actually, you know what? I'm not going to do example because I have examples coming up next. And you can also add, you can add multiple keys in a single statement. You don't have to keep doing, update JSON insert, update JSON, and you can do it all in one statement. You can update multiple properties. JSON replace does exactly what it says. It replaces the value of existing keys in a JSON document. What it doesn't do is it doesn't add that key to a document that doesn't already have it. And again, you can do you can update multiple keys in a single statement. JSON set will insert and update. What this means is if the key exists, it will update that key to the new value. If the key doesn't exist, it will create that key and then it will add that value to it. And again, you can also do multiple statements or multiple keys in a single statement. I'll show you some examples. For JSON insert, here we're doing update season, set season settings equals JSON insert, season settings, league fee, $25.50. So what we're doing here is we're saying we want to add the key league fee and we want to set it to $25.50 or 25.5. Now the season we just created, remember I said in the beginning we passed in that empty block? This is what you would see. You would see the league fee $25.50. But if you notice in an existing season, the league fee stayed the same. So the block on the right-hand side is from a season that existed before we started this process, but the block in the middle is the one that we created and we just passed in the empty object. For JSON replace, see here in the query, we're saying JSON replace season settings, golfers per team, set it to 4. In the middle object, which is the new object, golfers per team doesn't exist. It's not there anymore. Or I'm sorry, it's not there, it never was there. But on the old data, in any season that existed before that has golfers per team on it, it's set to 4. Now keep in mind with these update statements, you can also use a where clause as part of that. So if you only wanted to update a particular key or add a particular key to a particular season, you can add information to the where clause or if to make sure we're not doing, because right now we're just doing it globally. And I did that to show how when the stuff changes or when the stuff gets added. So now with JSON set, again, we pass in season settings and the path to golfers per team. And this time we set it to 2. So you'll see in the middle block in our new season, the golfers per team is set to 2. In the old season that already existed, it's also set to 2. So you need to try and figure out what it is. I actually think you're going to probably wind up using JSON set more than you will on any of the other two, but I can definitely see use cases where you would want to use one or the other. JSON remove. If you want to remove a key, you just pass in the column where the JSON is being stored, and then the path to the particular key that you want removed, and it will take it out of that JSON blob. Using relational data as JSON. Let's just say you have an application. Oh God, I got a lot. Got to go through real quick. I'm sorry. We have a function called JSON object, which takes arguments in sets of 2. The first argument in the set will be whatever the key is going to be named. The second argument will be the value. So if you see here, we have an object where we want to create ID, name, league ID, start date, season settings. And that actually will return that JSON blob from you. Notice I didn't have to do anything special for season settings. It knew that it was a JSON blob, and I just returned it as a JSON blob anyway. And JSON array ag, I talked about this before. This is just another example where we have a JSON object nested inside of a JSON array ag. So what this is actually going to return is an array of objects that match the keys that we passed in. Returning JSON as relational data. This is actually pretty interesting because if you look here, we're using the path operator. So we can actually we're doing select name, which is the name column from the season table. And then we're taking the course name from the season settings blob. And then we're casting the green fees that we take from the JSON settings blob. and we're pulling the handicap type from the scoring key of the season settings. And you'll see it actually returns it in tabular data. Okay. So MySQL Document Store, I'm going to have to go through this really quick. If anybody has any questions that I can't get to, feel free to stop me when we're done, because this is actually pretty good stuff. What is a document store? It's a JSON document storage solution built on top of MySQL. It is stored in a MySQL database, but it's actually abstracted from the user. So there's a very good, easy, I hate to use the word easy, but it is actually an easy API to use to get information there. Think of this as kind of like interacting with a MongoDB database. The advantages are it's ACID compliant. It's actually built on top of an InnoDB storage engine, and it uses the JSON data type underneath. And as I said, there's a very simple CRUD API for adding, updating, and removing and retrieving documents. How do we use it? Well, you need the X plugin. Fortunately, if you're using a newer version of MySQL, it's installed by default. It actually uses the X protocol through a MySQL connector. Right now, we have connectors for Node.js, Java, C++, Python, PHP, and .NET. The syntax for all of these is pretty much the same. There are a couple little bit of differences in how you need to lay stuff out and put the information in, but for the most part, they're the same. For the examples I'm going to show, this is actually, the code was actually used, I use MySQL Shell using the JavaScript support in MySQL Shell, which MySQL Shell can be a whole session on itself. Again, here's the demo schema. This is a little bit different demo schema. This schema is actually based on rounds of golf that people have played in the golf league. So we have the ID, which is automatically generated by the document store. We have a date, which is the date the round of golf was played, the score the golfer had, the course that it was played on, the golfer's last name, the golfer's first name, and the golfer's adjusted score. So first thing you got to do is you got to connect to the server. Now remember, all of these are commands you would run inside of MySQL Shell using the JavaScript support. And it's very easy to connect. You just do /c, username, password, @, the server address if it's localhost. You can put the port on the end if you want. You don't need to because it defaults to 3306. Actually, it defaults to 33060. The X protocol actually talks on a different port than regular MySQL does. It has a 0 on the end. And then you'll see a message like this: creating a session for user localhost, fetching schema names. So that's actually cool because you can actually start, hitting tab to have it autocomplete if you're dealing with the schemas. It'll let you know what your connection ID is, what version you're using, and it'll tell you that there's no schema selected. Use /use to get the schema. So working with the schemas, very easy comments here, or very easy commands here. Session, which when you make the connection, session is the object you're dealing with. You do session.create schema. Example, what that does is that's going to create a database or a schema on your MySQL server named example. And just like when you're running a SQL command, we have to tell document store which schema you want to use. So you do use example. Now, when you do /use and then pass in the schema name, you will get a message that lets you know, hey, we're now connected to this particular schema. If you want to access it, just use DB as the default. And that's going to come in the next slides or so. And then to drop the schema, session.drop schema. Very easy. Again, I don't really sing easy a lot, but. So when you have a collection in MySQL Document Store, a collection you have to think of as a table. So the schema is a database or schema, because they still use that. Those are kind of synonymous. A collection would be a table. So here, we're creating a collection or creating a table called round. And you see it starts with DB. So we ran this command after we did use schema name. Okay? And then you want to drop the connection or drop the collection, db.drop collection, and you pass the name of it, and it'll wipe everything out. This is what the collection looks like in a database. So if you actually run some of this code, and this code, there'll be a URL shortly to show you where all the code is that you want to run it. And you actually go and do describe round, because that's the name of the table we're creating. This is what it's going to look like. And if you look where the yellow arrow is, the doc column is actually a JSON data type. Creating documents, you do db dot collection name, in this case round, And then you pass in your JSON. So here, again, notice this isn't a string. This is actually a JSON, the JSON notation as it would be in JavaScript. And then that will actually just add it to the data. It'll actually insert that into the database. Searching documents. You do db.collection.find. That will return every item in that particular table. If you want to do different search criteria, you can do last name equals Stroz. You can do score less than 36. You can put different types of criteria depending on the data you have in the structure. And you can also bind objects. If you see here in the last one, we're actually binding the city property with the text Charlestown. You can also sort, limit, and offset the results. So you can pass an array of values for the sort, and it will sort by those just as you would in a SQL query. You can do limit, so you can say, give me the top one. Or if you're doing some type of pagination, am I done or just 5 minutes? Thank you. And then you can also do an offset. So this last one here is saying, give me 5 items, but start counting at number 6. So it skipped the first 5, and it will give you 6 through 10. What's returned is the data we put in the string. If you want to return specific keys, you use the fields method, and you pass in an array of the values that you want returned. And one thing to note here, if you look here, it says course.name as course name. So you can actually put aliases in the fields list. You can also do aggregate data in the fields list, which I'm going to show you soon. And you'll see here, this is what's actually returned. It's just a shorter version of what we had, and it's only the keys that we defined. If you want to group the results, there's a group by. And here we're doing, you'll see the fields property or the fields method. We're passing in course.name. We're rounding the average score of the course, and we're doing the minimum score and the maximum score for the course. And then we're grouping it by the course name. And that's what's returned. It actually, so if you saw in the fields thing, we not only were able to alias some of the data, but we're actually able to use MySQL functions to get that data. And lastly, and this is the more complex one, is using MySQL with Document Store. So if you already have the data in there and you need to do some type of analytics, and this is where I think MySQL Document Store has maybe a little bit of advantage over somebody else, because trying to run reports or analytics with MySQL Document Store is easier, because it's a JSON data type that's stored in a regular relational table. So if you look at item number 1, what we're doing is we're actually creating a CTE based off of the JSON data that's in the blob. That's in the document store. So we're pulling in the first name, the last name, the score, the course name, and the date plate. Then we're creating another CTE where we're getting the aggregates of that data. So we're getting the minimum score of the course of each different course. And then in the main query, what we're doing is we're pulling back the course information and not only the low score, but each golfer that shot that score on that course. That'd be something that would be a little bit more complicated to do with something like Mongo and other NoSQL databases. And this is what the information looks like. You see, we got the score. We have an array of golfers, which shows the name and the date that the score happened, and then the course name. To recap, there's Murphy again. We defined JSON and talked about some of the syntax. We talked about the differences between storing as a string as opposed to the JSON data type. Why we'd want to store JSON in a database, how to persist it, update it, and retrieve it. We talked about using relational data as JSON and the other way around. And you guys just got like a crash course in MySQL Document Store. These are the resources. The GitHub repo, that actually has all the code samples from here, as well as the data that I use. There's actually a script that you can run that populates the tables with all the data. MySQL documentation for JSON functions, as well as the document store concepts. And what was key for me putting this together is Dave Stokes, who used to work for Oracle in my position. He wrote a book about MySQL and JSON, a practical programming guide. That was a fantastic help in getting this done. And I'm sorry, I got 2 minutes. Does anybody have any questions? Yes, sir.
If I want to add or change in the schema, can we have auto statement or just want to complicate anyone?
I'm sorry, could you repeat that?
So in case if I want to alter the schema, JSON schema, do you have any alter statement or do I need to drop the table and keep it in there?
No, because are you talking about in the document store itself, or are you talking about in the JSON functions for relational? No, because you can just do JSON update, JSON insert, or JSON replace, and it will handle that for you depending on what you want to do. If you just want to add something new that doesn't exist anywhere in the schema already, you would just call, you would do update table name, set column name equals JSON insert, and then the property or the path to the property and the value you want.
What about in document?
In the document store, it's a little bit different because you can actually have completely different schemas in consecutive rows, because that's just the nature of the beast there. But you can there is actually a way in the document store to set up a schema definition that, again, like I showed you when we created the JSON data type, you can actually set a schema to say the schema, it must have this, or these properties must be required, these properties must be strings, or these properties must be numbers.
Thank you.
You're welcome.
So I guess we're out of time. Thank you, Scott, for coming.
Thank you.
down. And
Hold on, I do have a prize. How many people here know that the logo for MySQL is a dolphin? How many, first person, what's the dolphin's name? Nobody knows? I had a pair of sweet MySQL socks to give away. Actually, the dolphin's name is Sakila, which was it was a winner of a contest to name the dolphin. I forget exactly, it's from a language on the African continent. I can't remember exactly what language or what it translates to. Sorry. Okay, here's another one that you guys might know. What is MySQL actually named after? The developer's daughter. The my is not referring to the SQL belongs to me. The my is actually what he used, and that was the nickname he called his daughter. I'm sorry? Yes. But he would call her my or me is actually what I've heard that he used to call her, and that's actually where it came from. Did you look it up? Do you want the socks? I'm not leaving with the socks, so if somebody wants them, come get them. Thank you.
Thank you, everybody. Thank you, Scott.
Thank you.
Great conference ahead.
Thank you. Thank you for your help.